The connection between medicine and artificial intelligence. Is there a historical connection? In this episode, we trace the lineage of medical technology from Leibniz's 17th century logic to the 1970s Stanford MYCIN project. Our discussion is informed by the historical research of Dr. Edward Shortliff on expert systems and the foundational neurological models of McCulloch and Pitts. Check out Eric Topol's Deep Medicine for further reading on how history is shaping the future of the clinic.
Welcome back to the Neural Pulse, the podcast where we explore the fascinating frontiers of medicine and technology. I'm your host, Alex.
And I'm Dr. Sarah. It's great to be with you.
Today we're diving into a topic that feels like it's ripped from a sci-fi novel: the marriage of medicine and artificial intelligence. It seems like everywhere you look, AI is making headlines, diagnosing scans with superhuman accuracy, predicting global outbreaks before they happen, and even designing novel drug compounds from scratch. The potential is staggering, and it's happening right now.
It feels like a sudden revolution, doesn't it? From a clinical perspective, it's almost overwhelming. It's like we woke up one morning and the robots were suddenly in the ER, triaging patients and reading our charts. The pace of change is just breathtaking.
Exactly. But that's the question we're tackling today. Is this a brand new phenomenon, a sudden digital disruption, or is there a deeper, more intricate historical connection between the healing arts and the logic of machines that we've overlooked?
Believe it or not, Alex, the DNA of AI is actually woven into the very fabric of medical history, especially in the field of diagnosis. This isn't a sudden arrival. We didn't just stumble into this. We've been building toward it for centuries, piece by logical piece. The core ideas have been with us for a very long time.
Centuries. Really, Sarah? That sounds like a huge leap. The first computers weren't even built until the 1940s, and they were the size of a room. The idea of AI as we know it feels so modern, so rooted in the digital age. How far back are we talking? What's the connection?
It's a fair question, Alex. The connection isn't in the technology, but in the thinking behind it. Let's look at the philosophy of medicine. For millennia, since the time of Hippocrates, medicine has been about one thing: pattern recognition. A doctor observes a patient. You see a set of symptoms: a fever, a cough, a rash. You match it to a known condition, and you follow a protocol for treatment.
So, essentially, a living algorithm, a biological problem-solving machine.
Precisely. And that idea was formalized long before silicon chips. In the 17th century, the philosopher and mathematician Gottfried Wilhelm Leibniz dreamed of a calculus ratiocinator, a universal logical language. He envisioned a system where complex human disagreements could be resolved through pure calculation. He actually believed that one day, doctors and judges wouldn't argue. They would simply sit down and say, "Let us calculate."
That's incredible. So the idea that human health, something we see as deeply personal and complex, could be reduced to a series of logical computations is hundreds of years old. It wasn't born in Silicon Valley.
Exactly. The philosophical blueprint was already there, written in the language of logic and reason. We were just waiting for the hardware to catch up to the logic.
Okay, fast forward to the digital age. The world is changing. Computers are getting more powerful, but they're still these giant, mysterious machines. When did we first see a real medical AI emerge from that primordial digital soup?
The real breakthrough, the moment that set the stage for so much of what followed, happened in the early 1970s at Stanford University. A team of brilliant researchers developed a program called MYCIN. It wasn't AI as we think of it today, with neural networks and deep learning. This was a different beast entirely.
MYCIN sounds like an antibiotic brand. I feel like I've seen that on a prescription before.
That's exactly what it was for. It was one of the first expert systems. Think of it as a digital consultant. It used a knowledge base of about 600 rules, a vast library of medical expertise encoded into if-then statements. Its specific job was to identify bacteria causing severe infections, like bacteremia and meningitis, and then recommend the exact dosage of antibiotics based on the patient's body weight and other lab results.
That's incredibly specific. So it was like having a top specialist on call, but in a box. And did it actually work? Was it accurate?
It was more than accurate. In tests, it actually outperformed some medical students and even junior doctors in making correct diagnoses and treatment plans. But here's the historical irony. Despite its proven success, it was never used in clinics. Why not? If it was so good, why didn't it become standard practice? Not because the tech was bad, but because of the human factor and the physical reality of the time. The computers were the size of refrigerators, and the legal hurdles of who is responsible if the machine is wrong were too messy. Sounds familiar, right? These are the same debates we're having today, just with much smaller computers.
So, why did it take another 40 years for AI to become a household name in medicine?
We hit what historians call the AI winter in the 80s and 90s. We had the logic, but we didn't have the...
Right. A machine is only as smart as the information you feed it.
Exactly. Then came the 2000s. The digitizing of medical records, the Human Genome Project, and high-resolution medical imaging. Suddenly, we had billions of data points. The historical connection here is that medicine shifted from being a craft based on a doctor's memory to a data science that required the help of a machine to process.
So, when we see AI analyzing an MRI today and finding a tumor that a human eye might miss, it's not just a fancy gadget, it's the culmination of Leibniz's calculus and Stanford's expert rules.
Precisely. Even the way we train AI today, through neural networks, is modeled after the human brain. We are using our understanding of biology to build machines that, in turn, help us understand our biology.
It's a full-circle historical loop.
It really is. The connection between medicine and AI isn't a modern collision. It's a long-term evolution. We've always wanted to be more precise, more objective, and more efficient. AI is just the latest and perhaps most powerful stethoscope we've ever built.
That is a fascinating way to look at it. From ancient Greek patterns to 1970s mainframes, the road to AI-driven medicine is longer than we thought.
And we're still just at the beginning of the trail.
Thanks for joining us on the Neural Pulse. If you enjoyed this trip through medical history, make sure to subscribe and leave us a review.
Next week, we're looking at the ethics of robot surgeons. You won't want to miss it.
Stay healthy and stay curious.